Friends, we are discussing about arrays and data structures in some parts. In this particular slides, we want to discuss about how we can manipulate Numpy arrays. Particularly, we will discuss about how we can insert or delete data or elements in an array, how we can split an array, how we can append or append data or some element with an array, how we can stack different arrays, and so on. Okay, so first, inserting elements. Suppose this is an Numpy array, one-dimensional array. So with this method a.put, so put is now an attribute to a is a Numpy array, so a.put, and you write inside 3,99. 3 is the index position and 99 is the element you want to put. So with this put method, what you can see is that the result is this. So this is 0th position, first position, second position, and this is the third position. So what it has done is basically it has replaced this 5. So 0, 1, 2, 3. So in the third position it was 5, this element, but what it does is that it replaced this element and now it is 99. Okay, so there is another way we can do that. np.insert. So in this we can write a is the array, and 3 is the index position, and 99 is the element we want to insert. Well, so now this is little different in a way that you can see that this is 0th position, first position, second position, and the third position. So look at the original array. So now the element which was in the third position here, now it remains. It just replaces it, not replaces it. It takes it. It pushes it away. Okay, but in the other method, it actually replaces this. So you have to be careful about which method you will use when you want to insert some data, either put or insert. It is according to your choice. Well, now look at the another array. So this is a two-dimensional array, 1, 2, 3, 4, and you want to insert one array, one list. This is the list, but you want to put this list with this two-dimensional array. But you have done some other things here. A is the np.insert, but you have said here an array, name of the array, then position and the element, the whole element, and you also have mentioned here with keyword argument axis equal to 0. That means where it will insert with this two-dimensional array. So it is said the axis is 0. Let us see what is axis is 0. So the result is this. That means the element wise, this is the first element, first row is the first element, I mean 0th element. This is the first element. So in the insert, with the insert, it will insert here in the first position. So this is now the 0th element, this is the first element, and this is the second element. So it will push this away, but in which direction? It will be in this direction, in this vertical direction. So axis equal to 0, the reference means it will insert in the vertical direction. So this is what means with axis. Also, you can write this way: a, 1, 10, 12. You want to insert this same thing, but with axis equal to 1. That means, let's see. So it is axis 1 means it is on the horizontal direction. So always remember, so whenever you are dealing with a more than one-dimensional array, so there are axes. In the two-dimensional array, this is in the vertical direction is axis 0. In the horizontal direction, this is axis 1. So it has inserted 10, 12 in this is the 0th position, 0th in this way, 0th, this is the first position, this is the second position along the horizontal axis. So it has placed 0, 12 here. So next if you write a comma 1, and this is basically a scalar, it is inside an array, but this is single element. But A is different. A is a 2D array and it has 2 rows and 2 columns. Now see what it does. Since you have not mentioned any axis, so it could not match where it will put, because A is a 2-dimensional array. So in this case, it has kind of it is a punishment kind of that is, it has flattened the array. See, 2D array 2, it has now become 1D array, and it has put this 10 in the 1th position. So 1, 2, 3, 4 were the original elements, but it was a 2D array. Now it has placed 10 here and it has flattened here. Similarly, if you want to put 10, 12, this is the 1D array. This vector you want to put in A in one position, it will also flatten this, because it doesn't, you have not referred the axis, so it doesn't know where it will put, in vertical direction or in horizontal direction. So remember, if you miss, in this case, if you miss to mention with the keyword argument the axis, it will just flatten and it will do the job. So it will basically flatten when there is no reference of axis. Well, now if you do the same thing, a comma 1 comma 10 12 and axis equal to 0, of course it will do the same thing. But if you now write x is equal to 1, of course it will place it here, as we earlier seen. Okay, now in this case, suppose you write a comma 1 comma, this is a scalar 10, but it's an array, one-dimensional array, and you referred axis equal to 0. Let us see what it does. Well, it is axis 0 means it will place in this direction, but this is a single element, and but the original array is 1, 2, 3, 4. It is a 2D array, 2 in the rows and 2 in the column. So what it will do is that it will match this. It will match this. It will write 2 10s here instead of 1. So from the scalar, it has made it first as a vector and matched it and cleverly placed it in this position. So this is very nice. So if you write this way, so it's the same thing with axis equal to 1. It will also do the same thing, but in this horizontal direction. So it will place it here. Well, so now delete. So suppose you have created an array like this. If you remember this, it is just to create the array in p.arange 1 to 13, and then we reshape this with 3 by 4. So it's a 3 by 4 array, 2D array. So now we want to delete one element, and we have also referred the axis. So np.delete, delete is the method, and you put the name of the array, then the index number, and then the axis equal to 0. Axis equal to 0 means in this vertical direction. So this is the basically in this direction. If you go in this vertical direction, so this is the 0th element, the next row is the first element, and this is the second element. So it is telling you that you delete the second element in the second position 2. That means the result will be the last row will be deleted. So you see 1 2 3 4 5 6 7 8, and this row 9 10 11 12, this row is deleted. Now if you write np.delete x comma 2 and the axis equal to 1 with the same array, but you want to delete on the horizontal direction, because in this x is equal to 1 means in the horizontal direction. So that means this is the, in this if you go in this direction, so in this case this is the 0th element, this is the first element, and this is the second index number 2, index number 0 1 2. That means you expect that these 3 7 11, this column will be deleted. Let us see what we can see. Oh yes, so this column 3 7 11, this column is now deleted. Okay, now we want to split. What is split? Suppose this is an array, 2D array again, 1 2 3 4 these things, so some 3 by 4 matrix like. So you want to split this. So the split is the method np.split. Inside that you write x comma 3. That means what it does? That means it actually makes it 3 pieces. So split means it is just cutting. So see 1 2 3 4. If the first row, it is now as separate array. In the second row, it is now a separate array, and the third row, it is another piece. So you have got 3 equal pieces, and all those are confined in a list. So the result is a list of 3 equally equal arrays, equal pieced arrays. Okay, so this was only split, but now you want to mention that it is vertical split. Vertical split means, see what it does. It actually does the same thing. Vertical split means it's not that cutting this way. Cutting this way means vertical. V split means you actually come into vertical direction. That means you come vertical direction, you got one piece, one row, then you approach in this direction, you got another row, and then another row. That means 3 equal pieces. So it will give you the same result. So np.split in this case and np.vsplit gives you the give you the same result. But of course you can try on interpreter. If you, instead of 3, you can write 2 and check what it does, because it has 3 equal pieces. Whether it will give you 2 pieces or not, or it will give you an error. This is an exercise for you. You can try on your interpreter and check yourself. Okay, but one thing you remember, whatever we do, we split or whatever, in this case the original array x does not change. So it will give you, suppose this in this split method, it will give you a list of 3 cut piece arrays, but the original array will remain the same. Okay, and see H split, horizontal split. That means you go in the horizontal direction and go on splitting. But you see the in the horizontal split, we write here x comma 4, because we had 4 columns. Otherwise, it would not make you 4 equal pieces. Okay, it would give you error probably. You check. So if you do this, it will give you an array, a list of 4 arrays, because you see you had the original array like this. So if you go on in horizontal direction, so this is one piece, this second column, this is another piece, third column, fourth column, they are different pieces. So you get this result. Okay, so append means, we know from the basic Python, in the list, append means it will insert the data from the right end. So this is an array 1 2 3 4, and you want to append 7. So you write np.append. This is the method. Append is the method, and x comma 7. That means the 7 will be appended at the end. Now, if you have the array like this, say 10 20 30, and you have another array x y equal to, say, 100 20 200 300. two different arrays, and doesn't matter whether they are of equal size or not, but equal dimension, of course, here. So if you write np dot append x comma y, so basically they join one with the other. So first is x, second is y. If you write y comma x, then of course you would see first this and then this. Okay, so this is your append. Now you have, say, a equal to a is this array 1 2 3 4. Now you append a comma 99. So this is 99 is just a single element, and this is a 2D array. So let's see what it does. Oh yeah, it like before, it will flatten because you have not mentioned any axis or anything. So it doesn't know where to append, is this direction or that direction, and also it cannot match with the form of the shape of the data here. So what it will do is that it will give you something, it will flatten this and it will put at the end. Well, flattens and appends. Now if you write, okay, 1 2 3 4, and then you write np.append a comma, so it is a 2D array, and so you write the data which you want to append, which is of the same form. See, two square brackets here, two square brackets here. So that means this data is a 2D array, and your A is also 2D array. So at least the shape matches. So if you do that, it will still append, but it will still flatten and append because we have not mentioned the axis. Well, let's see even more. You do the same thing. You have your A, and the shape of this matches with this because it is 2D array. This is a 2D array. Of course, this is 2 by 2, but this is 2 by 1, of course. But one dimension match, one direction. But you have told that axis equal to 0. That means you want to come to this vertical direction. Okay. So now it knows that where to fit the data, where to append, because clearly this is the array A 1 2 3 4, and on the axis 0, that means you come this direction and it will clearly append this 9 10 in this form. So it will maintain the form. So now it becomes an array of 3 by 2. Well, now try to do this. np.append a comma this, and you are wanting to append this on the horizontal direction, but clearly this won't match with this, so the result will be some error. It can't match. But this can be correct. This can be done in a better way with stacking. So stacking is very, very important in Python, in Numpy arrays, because often you will deal with many arrays, and you will have to stack one array with another for your programs or so on. So in this case, x is a 2D array 1 2 3 4 2 by 2, and y is another 2D array 2 by 2, and you want to stack x comma y. So you write x comma y like in terms of tuple. So you put this tuple inside this stack method, stack function. So the result is, as you can expect, you have not said any axis, but automatically it has assumed that you will stack one and behind the other. So the first one will be here and the second one will be below. So the axis it has automatically chosen in this vertical direction. So the default axis is 0. Now you can mention x is equal to 1 or x is equal to 0. If you would mention x is equal to 0, it would give you the same result that you already got. Now if you write np.stack x comma y is like a tuple and x is equal to 1, you will get something. It is trying to stack in this horizontal direction, because axis 1 is in this horizontal direction, but in this case it has something, it has mixed. You see, the first array was 1 2 and 3 4, and the second array was 5, 6, 7, 8. But this is something you may not want, or you may want if you want. So in this axis reference, axis equal to 1, it did not actually write side by side, but it has mixed it. So you can do it better with a specific function which is called vstack. So it stacks vertically. So if you write this vstack x comma y, you have vstack and hstack. I'll show you both. So if you so ordinary stack was like a vstack. So ordinary stack with axis reference equal to 0 is this 1, 2, 3, 4 and 5, 6, 7, 8. But if you write np.hstack and you write x comma y, and you need not refer axis here or axis here, because it is automatically telling you that it is vertically direction and this is horizontal direction. So now you see this is what you could imagine. So this is the first array and this is the second array. This is x and this is y. So it is stacking the two arrays side by side. That means in the horizontal direction. Okay, so again, suppose I have an array A and another array B. So but you see the array A is 2D array, 2 by 2, and the array B is 1D array, it is 1 minus 1. Now if we try to stack them A comma B, they are not of the same dimension, but it is, see, it is 2 by 2 and it is 2 by 1 by 2. So if you do that, it will automatically match with this. Try to match with this. So 1, 2, 3, 4, and so the columns match. It has 2 columns. If you want to see like that, it has also 2 rows and 2 columns. So this, since a column matches, so in the vertical direction it can place it. It's like when you put Lego pieces one onto other, and if it fits in one direction, then you can exactly fit there, you can place there. Okay, so that it is like that. So if you are vstacking this, it is matches, the columns match, so it places here. So this thing is called technically broadcasting. That means the data, this data is broadcasted in the form of the previous this data, and it has placed like this. Okay, so similarly, if you have B like this, B is now it's like a column. It's like a column matrix. So it is basically 1, 2, 2 rows, 1 column. So if you now do with hstack A comma B, if you would do it vstack, then it would give you some error. But now if you write np.hstack A comma B, now you see what it does. In the horizontal direction, it stacks. So 1, 2, 3, 4 is the original this array A, and now it is stacking here because at least it has 2 rows and this has 1 row, 2 row. So here it is. See, we are going in this horizontal direction, so the rows are matching here. This row, this row. So it has matched, and this is also called broadcasting. So this is the end of the part 3. See you in the